So each angle in a pentagon, each angle is what?
108.
108. So 5n minus 2 times 180 times 3 over 5. So 36, 108. So let's draw a pentagon. Regular pentagon. The length is 150. So let's calculate this one first. 108. 150. 08, 72. 150. Okay, something like this. And okay, so this one is 250, 108. It would be 142. So 142, 1.5, and this, right? Okay, it is A, B, C, D, E. And then it says the 5 vertices of the pentagon are folded into the center of the pentagon. Okay. If you want to find center of this pentagon, so here, for example, it is 70. We know it is, this one is 108, so half of that is 54. So it lies on this, and this one is, 72 with this one. So 108 over 2 is 54. 54 plus 72, 126. It will be something like this. So it is our center, right? Okay.
Yeah.
Can you tell me, if you want to create new pentagon, then the figure would be what? For example, it is A. How can I find A prime?
Into the center.
A goes to the center, right?
Yeah.
Okay, when A goes to the center, what happens to the, for example, new, if you want to create new pentagon, the figure would be what?
It would be like this pentagon rotated 180 degrees.
Yes, if we connect, for example, A to this one, so when A goes here, you should consider perpendicular bisector, right?
Yeah.
Let me copy a regular pentagon with center. Okay. One regular pentagon is, okay, copy. Let's try, let me copy the photo, copy the image. Okay, so let's try this one here. Okay. Now, if we consider this one, can you tell me the new pentagon? How can we create new pentagon? B, C, D, E. Okay. The center lies here, right?
Yeah.
Okay, let me make it bigger. Okay. A lies here. We can also say, okay, D is 54, 53, 54. Okay, our center is this O. So how can we create new pentagon? When A goes here, do you agree we should consider midpoint of this perpendicular bisector of midpoint of this because we want to reflect with respect to that line. So if we consider that one, so look here, the length is 4. We should consider 2 around this one, and it would be this. Do you agree when you hold A to O, then we have this line as one edge of regular pentagon?
Yeah.
Okay, so if we connect all points to this O like this, so we should, let me erase this one, connect only A to O, this one to this. Okay, so here, if you want to consider this one, it is what? It is the gain 4. You consider 2, and the angle is what? 340, 90 to 50. Okay. So next line is this green line, right?
Yeah.
Again, this one is 4. It would be around 4. Let me check. It's around 385. Okay, 396 is around 2. Okay. So 198 minus 90 is 108. This one has 4. Then it would be 2. Okay. So 124, 90, 34. Okay, and last one would be what? Again, you can say it's 4 becomes around 2. And then this one is 53, 143. Okay, these are our new vertices. So it would be D, because we have the E, let's write F, G, let's write in this order, G, H, I, J, right?
Yeah.
Okay, so then it says what? It says, okay, we know a regular pentagon area is this, and now what's the area of new pentagon? So we should find the ratio of these two pentagons, right?
Right. Okay.
Because they are similar. So, for example, you can say side length is A or something like that. Then this side length is what in terms of A? Okay. So your figure is this or not? Your figure is this or different?
My figure is very different, but it's fine.
No, but the figure is this, if it's your exact figure. So you should consider, for example, AB is A, then this one is what in terms of A? One hint for this one, or want to try first on your own?
Can I have a little hint, please?
Okay, sure. So this one is A. What can we say about AO?
AO is equal to EO.
Yes, all of them are equal, but they are what in terms of A? Let me just tell you something. We know center of ABCDE is O, right?
Yeah.
So O is equal to O center of ABCDE. Can you tell me center of FGHIJ is what?
Of FG. Isn't it also O?
Yes, why?
Because they're similar?
Because of symmetric, we can say this, right?
Symmetry, yeah.
We can say this length is equal to this length by symmetry, so OI is equal to OX similar to OJ. So this one is set. Now we know OA is radius of this one. So do you agree if we, for example, find OI over OA, the problem will be solved? Agree?
OI.
Because we want to find the ratio of these two similar figures, right? So
Right.
at first I wanted to find ratio of sides, but I saw that, okay, radius seems to be better. Do you agree OI is also equal to AI, right? So let's consider this one big R. Oh, so it is R over 2, R over 2. OI, this one a small r. So if you find big R over a small r, the problem will be solved, right?
Yeah.
Okay, want more hint or that's enough?
I'll try, but I probably will need more help.
Okay, related to the angles, okay? Find its sine of something or cosine of something related to it, okay?
Okay. I don't know how to find like sine of 36 or 54.
Exactly. We should relate it something like that. This angle is what?
That's 36.
Yes, you should divide this by 10. It's 36. So here we know if you want to find this ratio, for example, cosine 36 is good, right?
Yeah, but I don't know. That's
Cosine 36 is what over what?
R over 2, big R over 2 small r.
Yeah, so it is r over r, 2r. So r over r is 2 cos 36, right?
Yeah.
Okay, so we should find r big R over. The answer is big. Let me tell you. The answer is what in terms of a small r and big R? Let me copy the problem. The answer is what in terms of big R and
Small r over big R. Wait. Oh, I don't. Small over big R squared times square root of 5 plus 1.
exactly, which is 4 times root 5 plus 1 times cos squared 36, right?
4
Agreed?
times.
Ah, sorry. It is in the denominator. So, a small r over big R is root 5 plus 1 over 4 cos squared 36, right?
Yeah.
How can we relate cos squared 36 to cos 72?
Cos 72 is 2 times of 36.
No, try again. Find this one in terms of cos 72.
No, it's like half of 70.
Half of, yes, half of what?
One plus cosine 72 over 2.
1 plus cos 72 over
2.
2, exactly. So, do you agree? We should find cos 36, or if we find also cos 72, the problem will be solved, right?
Yeah.
Or what? What are the other things that if you find it would be okay? Cos 72 is equal to sine what?
Cos 72 equals sine 18.
Exactly. If you find any of them, it will be okay, right?
Yeah.
Okay, now for this part, let me tell you hints. Then when we find these, we can find all of them. For this one, we have an approach. It's famous. You can say alpha is equal to 18, okay?
I got 5 alpha.
Alpha is equal to 18, then 5 alpha is 90, right?
Yeah.
Then do you agree sine 2 alpha is equal to sine 90 minus 3 alpha, right?
Yeah.
So it's equal to cos 3 alpha, okay?
Yeah.
So we have sine 2 alpha is equal to cosine 3 alpha. Then you can use this. You can use trigonometric formulas to simplify, and then you can find sine alpha is what? Okay, you should simplify both sides. Want more hint or that's enough?
I'm not. Okay, I'm not that good with.
For example, this one, sine 2 alpha is what? Is 2 times what times?
2 times sine alpha, cosine
Exactly.
alpha.
Then for cos 3 alpha, write cos alpha plus 2 alpha, then apply for cos 2 alpha, then you can simplify and you can easily find sine alpha.
Okay.
Okay, try.
Okay. I got that sine alpha is -1 plus minus square root of 5 over 4.
Minus 1 plus minus the square root of 5 over 4, right?
Yeah.
We should select minus root 5 or plus root 5. So which of them is our answer? Plus root 5 or minus root 5?
It's plus, right?
Why?
Because it has to be positive. Because it's
Yes,
two
sine
side
alpha should be positive because it is between 0 and 90 alpha, right?
Yeah.
Okay, and here sine is positive from 0 to 180. Okay, let's check. Here we write it as cosine alpha, cosine 2 alpha, minus sine alpha, sine 2 alpha. Then, what can we do here? We expanded cosine 2 alpha, right?
Yeah, I could expanded cosine to alpha
It will be
and sine to
cosine
alpha.
alpha squared minus sine alpha squared, right?
Yeah.
Then what? Here also you can write 2 sine alpha, cosine alpha.
Yeah.
So if you write, it will be 2 sine alpha. Cosine alpha is equal to, if we write this one first, it will be minus 2 sine alpha squared cosine alpha, right?
Yeah.
Then if we write this part, we can say cosine cube alpha minus cosine alpha sine. So let's write cosine cube alpha minus cosine alpha sine squared alpha, right?
Yeah.
Then we can do what?
I divided everything by cosine alpha.
Yes. So 2 sine alpha is equal to negative 2 sine squared alpha. And how here, if you consider both of them, it's negative 3, right?
Yeah.
Sine squared alpha plus cos squared alpha. Then what?
And then I changed cosine squared alpha to 1 minus sine alpha.
Yes. So if you take all things to the left side,
You get
it is
4
4
sine
sine
alpha.
squared alpha, right?
Yeah, plus 2 sine alpha minus 1 is 0.
Exactly. So sine alpha, as we said,
It's x.
is equal to, yes, minus b plus minus 4 minus 4 plus 16 over 8. So sine alpha is equal to negative 1 plus minus root 5 over 4. And because it is positive, so sine alpha, as you said, is root 5 minus 1 over 4, right?
Yeah.
Okay, so sine 18 is root 5 minus 1 over 4. Now that you found this, you can find the answer of this problem, right? And you can memorize this one, okay, for other problems. Then you can use it quick. Okay, calculate the answer is what?
I made a calculation error somewhere.
Okay, let's try it. You know, sine 18 is this, so it is equal to cosine 72, right? Agreed.
Yeah.
So if you simplify it, the denominator is 8, the numerator is what?
Wait, is cosine... What's the relation between cosine 36 and cosine 72 then?
This one.
Okay. Yeah, okay.
Okay, so the numerator is what?
3 plus square root of 5.
Okay, so it is 4 minus 1, 3 plus root 5.
Wait, I can do the calculation again. Okay, I got B.
You got B?
Yeah.
Okay, let's check. This one 4 times is 2, then you can say 2 times root 5 plus 1 over 3 plus root 5. So we should rationalize it. It is 9 minus 5, 4. So we have 2 and root 5 plus 1. 3 minus root 5. So if we calculate it, it is 1/2. 3 root 5 minus root 5 is 2 root 5. 3 minus 5 is -2, so it's root 5 minus 1, right?
Yeah.
Yes, good job.